Hey guys, it's Monday, May 18th. We're going to keep going in chapter 10 this week. Here's our week at a glance. It's everything we're going to do. I've gotten some questions about the notes. I realized that you guys ran out of notes as of 10:1. The notes are available for you to print on the website if you want to and have a printer available. I know a lot of you don't have a printer, and that's totally okay. You can take your own notes. You can look at my notes and take them on your own, or you can use the book for notes. Whatever works for you is fine. If you can print the notes, they're a great learning resource for you to write with me. We're going to go right along with them like we always do. So feel free to pause right here and look at the week at a glance. This is everything we're going to do. This is what you would write in your planner to make it easier to manage your classes. I know it's been overwhelming to manage your classes this way with distance learning, so consider writing in your planner. It will be helpful. Here's our warm-up for this morning, or whenever you watch this. Give it a shot. It's just multiplication. Of course, you're allowed a calculator because I'm not standing there to make you not use a calculator. Normally, we probably would still use a calculator in this chapter since it's the last chapter and it seems applicable. So give this a shot, pause the video, and then we will review. Alright, so here we go. 3 times 4 is 12, and 12 times 5 is 60. 7 times 3 is 21, and 21 times 6 is 126. Five times 5 is 25, and 25 times 4 is 100. Okay, so we're going to start off with this example about pizza. So it says, you randomly choose a crust and style of pizza. Find the sample space. We need to talk about that word sample space. Sample space is all the possible outcomes. All the possible outcomes are called the sample space. It's like a list. Sometimes it's a tree, sometimes it's a diagram. It's a list of all the possible outcomes. So here comes the question. How many different pizzas are possible if you were to choose randomly? So you might organize your thoughts like a tree. And that's how I've done this example. So you can have a thin crust. I'm going to abbreviate thin crust. You can also have a stuffed crust. Those are the two crust choices. Then you could have a thin crust Hawaiian style pizza. You could have a thin crust Mexican style pizza, a thin crust pepperoni pizza, or a thin crust veggie pizza. You could also have a stuffed crust Hawaiian style pizza, a stuffed crust Mexican style pizza, a stuffed crust pepperoni pizza, or a stuffed crust veggie pizza. Then we want to look at how many options are there. And you're going to count the last row. So there's 1, 2, 3, 4, 5, 6, 7, 8 possible pizzas. Now, as you may have guessed, we're not going to draw a table or a tree for very complicated examples. There's a shortcut. There's a way to do this mathematically. It's called the fundamental counting principle. We can use the fundamental counting principle, which, as you guessed it, is multiplication from the warm-up, to find out how many possible outcomes there are in a given event. And we're just going to multiply the possibilities of the first event times the probability of the second event, the total outcomes. So let's practice. It says find the total number of possible outcomes of rolling a number cube and flipping a coin. So there's two events here, right? Rolling a number cube and flipping a coin. And the question asks us to find the total possible outcomes. Well, how many outcomes are there of rolling a number cube? There are 6. There are 6 sides to a cube, 1 through 6. How many outcomes are there when you flip a coin? There are 2, heads or tails. To find the total possible outcomes All we need to do is multiply. Total possible outcomes is 12. This is called the fundamental counting principle. Let's practice some more. Now, if you have the notes in front of you, this picture is kind of hard to see because the colors are black and white. So look at this picture. You can also look in your book. It's in 10.4 to see the colors a little bit more clearly. And the question says, how many different outfits can you make, or total possible outcomes, from the t-shirts, jeans, and shoes in the closet? All right, I don't know if you can see clearly here, but there are 4 jeans. There are 1, 2, 3, 4, 5, 6, 7 shirts, and 3 pairs of shoes. We're going to use the fundamental counting principle to find out how many possible outcomes there are by using multiplication. So 4 times 7 times 3. 4 times 7 is 28, and 28 times 3 is 84. There are 84 different outfits in the closet. Let's practice a few more. You'll encounter a question like this on the homework this afternoon or tomorrow. A lock is numbered from 0 to 9. Each combination uses 3 numbers in a left or a right, left, right pattern. Find the total number of possible combinations for the lock. This is like your PE locker, where the first number is right, the second number is left, and the third number is right again. So there's 3 digits. And we want to know, what are the total possible outcomes? Well, how many outcomes are there for the first number? Be really careful. A lock is numbered from 0 to 9. There are 10 options available. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, some locks don't allow you to use repeat digits, so it gets a little bit more complicated here. But for the second digit, there's 10 possible. And for the third digit, there's 10 possible. Now we're going to use the fundamental counting principle and use multiplication. So there are 1,000 possible outcomes, 1,000 possible combinations on the lock. Let's keep going. Find the total possible outcomes of spinning the spinner and then choosing a number from 1 to 5. How many outcomes are there of spinning the spinner? 1, 2, 3, 4. How many outcomes are there in choosing a number from 1 to 5? 1, 2, 3, 4, 5. Fundamental counting principle says we can multiply. There are 20 possible outcomes. All right, let's try one of these. When you're finding the probability of 2 events, this is a review from 10.3. When you find the probability of 2 events, you need to find the probability of the first, the probability of the second, and multiply. It's helpful to know what the possible outcomes are because that's going to be your denominator. So the probability of rolling a number greater than 4 on a number cube. There are only 2 outcomes on a number cube greater than 4, 5 and 6. So 2 of the 6 are greater than 4. The probability of flipping a tails is 1/2. To find the probability of both together, we multiply. And I'll get 2 over 12. But you can reduce that. Or you could cross cancel here if you want to. Oops. 1/6 is your probability. Let's see if we can find one more to try. Okay. What about this one? Number 4. In example 2, what is the probability of rolling at most a 4 and flipping a tails. So on a number cube, at most a 4 means less than 4. How many outcomes are less than 4? 3 outcomes are less than 4 out of 6 total sides. And the probability of flipping a heads is 1/2. To find the probability of both, we multiply. Nothing to cross cancel, so we'll get 3/12, which we can reduce to 1/4. Right, 3 goes into 12 evenly. Summarize those notes about fundamental counting principle, and I'll see you soon.